I've drawn here the intensity profile of the fringe pattern formed along the screen. 0th order, 1st order, 2nd order, and so on. Let's say the amplitude of each wave is A. So during constructive interference, the resultant amplitude is A plus A, which is 2A, which corresponds to an intensity of 4I. During destructive interference, the resultant amplitude is A minus A, which is 0. That's why the bright fringes have an intensity of 4I, and the dark fringes have an intensity of 0I. So now we are going to reduce the intensity of the light through one of the slits. Let's say the amplitude of the reduced intensity is 0.5A. So during constructive interference, we are going to get the resultant amplitude of A plus 0.5A, which is 1.5A. And this will correspond to a intensity of 1.5 square I. So 1.5 square is 2.25. During destructive interference, the resultant wave's amplitude will be A minus 0.5A, which is 0.5A, which will correspond to an intensity of 0.25I. So with one of the slits intensity reduced, the bright fringes will have intensity of about 2.25I, and the dark fringes have an intensity of 0.25I. So the bright fringes are now dimmer than before, but the dark fringes are now brighter than before. The bright fringes are dimmer than before because one of the wave has a reduced intensity now. The dark fringes are brighter than before because we no longer have a complete destructive interference. And this results in an interference pattern that has less contrast than before. Okay, that's all. Ta-ta.